City C.E.D. Reinventing Human Habitation at the Wildlife-Urban Interface through Combinatory Urban Morphologies. A project by Esteban Ley under the instruction of Ronald Rael. The City C.E.D. project is a speculative proposal for the redevelopment of Paradise, California, and the envisioning of a new paradigm for human habitation at the wildland-urban interface. The project's premise is to establish economic and fire resiliency in Paradise, to provide fire-resistant shelter post-fire disaster, and to dramatically re-envision urban morphology and materiality. With the threat of fire disaster growing year by year in Northern California, it is critical that fire-resistant materials and urban planning be utilized to minimize the burning of our built environment and to build stronger, more resilient communities. In 2018, Paradise was struck by the Campfire, one of the deadliest forest fires in California history, which led to a tremendous loss of life. Thousands of homes and commercial structures were destroyed due to the fire, leading to a huge exodus from Paradise in the aftermath. The City C.E.D. project includes the design of several buildings situated in a new master plan for Paradise. The plan will phase in the construction of 4 multi-use communities, which will provide Paradise with fire-resistant homes and public structures. The central concept of the City C.E.D. project is taken from the heart of the problem of wildfires, and from the beginning of any forest, the seed. As if planting the seed for the growth of a new forest city, this project looks into the future of how new homes and shelter can be constructed with fire-resistant materials and fire preventative planning strategies. The city uses 3D printed earthen construction, terraforming, and troglodyte subterranean dwellings as a code or DNA for future growth. This city will use the refuse of the 2018 Campfire as a resource for new construction. The planning of a series of tree farms and managed natural forests in adjacent areas of the burnt city will provide future building materials and could one day become a future site for earthen construction. Increased density of residential, commercial, civic, and recreational functions minimizes the amount of dispersed rural dwellings, which often contribute to bad forest ecology and risk of fire damage. While the City C.E.D. project is primarily new construction, a complex palimpsest of new and old is produced by preserving major road networks and large portions of central Paradise. The primary fire-resistant measures of the city lie in its excavation of earth and subterranean spaces. The primary residential component of the project is its grid of homes dispersed across the site in the form of subterranean courtyard dwellings. Their central courtyards act as a central circulation space and give residents the ability to take shelter under the earth in case of fire. As another key fire-resistant measure, the combinatory form provides space for new water reservoirs, which have a dual function as park amenities and as water storage for use in putting out fires. The project's combinatory formal strategy is explored through various architectural models at several scales and produces a multiplicity of microclimates and spatial conditions throughout the city. In the generation of these forms, a complex aggregation of various prototypes is achieved through parametric randomization of rotation, scale, and frequency. A rich underlying system is produced by the Boolean relationship between these objects to each other and to the origin surface or field condition. The introduction of a variety of formal prototypes also allows for the negotiation and incorporation of water reservoirs, public recreation spaces, and tree farms into the urban landscape. The project critically reconsiders the ground plane as a hybrid of synthetic and natural landscapes. The courtyard prototype is the primary residential component of the development. The network of single-family homes creates an interconnected field across the site. Each home benefits from passive heating and cooling thanks to the temperature of the earth. Terracing and circulation down to the courtyard home maximizes southern exposure and increases availability to natural light. Each home is radially planned around a central garden and courtyard. The spaces deeper in the earth act as shelters from fire and receive natural light from skylights. These subterranean spaces would be constructed with 3D printed earth, concrete, and small diameter timber framing. The excavated earth gathered from each home would be saved as a resource for constructing other buildings on the site. The final prototype explored by this project is the ring prototype, which can be seen across the site at the location of several water reservoirs. Water is contained by this massive outer concrete ring. Some of these small lakes will be available for public use as amenities and parks, while others will be reserved for firefighting purposes. The ring typology seen in this physical model shows how these forms can be segmented and constructed as buildings. These extruded building forms function as educational or medical facilities and are connected to other commercial and residential areas through public metro systems. The slanted floor plates of this building accommodate auditoriums and lecture halls. The primary horizontal circulation at the core of the building connects several building chunks as sky bridges, while the vertical circulation is achieved through the addition of a series of rectilinear cores. Seen in this physical model are the additive mound building types aggregated across the site. These building types take on a variety of construction techniques and sectional properties. These prototypes are typically planned as multifunctional buildings across the site, housing commercial, civic, and multifamily residential functions. The mound form is designed as a green hill with subterranean troglodyte spaces on the interior. Its primary vertical circulation is located at its core, with horizontal circulation weaving in and out of the hill at its circumference. Large atriums and skylights allow light into the interior of the mound. By maximizing the earthen exterior and minimizing exterior facades, this building becomes protected from potential fires. The third and final construction type would be a free-plan tower with a non-structural glass and ceramic skin. Its primary structure is a small diameter timber structural frame and a vertical core. The ceramic facade is sourced from local clay and provides the building with shading and fire protection as a fire-resistant and anti-corrosive material.